Well, here we are. This is a M-Tech brush drive motor for a vacuum cleaner floor brush, and we just cut off the connector like this, and we're going to wire it up to an extension cord so we can run it on 110 volts, because that's what it is. It's a 110 volt motor. But you can do a lot of experiments with this little motor, and we're going to try to show you all the fun you can have with the motor. We're also going to, because it is powerful and it should be mounted normally, we're going to just stick it in this. And we're going to run it in that, and you can see how fast it goes. And you hear the noise. So here we go. Probably 15,000 RPM, could be 20. Anyway, it really goes. That's at 110 volts. Now we're going to run it on 12 volts. It would be much slower. You couldn't stop it with your hand with this. But this is 120 volts, but we're going to run it now on 12 volts. We have a little transformer here that puts out 12 volts. It's got a cigarette lighter adapter on it. It puts out 12 volts. Puts out 12 volts, 5 amps. Anyway, we're going to run it on that. You can see what it'll do. And we'll just do it with these clips here. You wouldn't think it would even run. This is 12 volts DC now, not AC like we were just running it on. That's 12 volts. That's 1/10. But really, all AC motors with brushes are DC motors also. And you see, you can stop it. But it does run pretty good on 12 volts. And it's going counterclockwise. And either way you hook up the 12 volts to it, it still runs counterclockwise. So this is what the field looks like inside. This is the field, and the wiring you see there. The wire comes up to here, goes through here, comes out here, right through that wire there, connects to here and goes through a brush, to an armature, to a brush, to that one, and it comes all the way down here, through this, and it goes in the yellow wire, out to the outside. That's called series wiring, and we're going to eventually change one to parallel and see the power you get with 12 volts instead of 120 in parallel. Makes quite a difference. I'll show you some of the other parts. These are the brushes. This is the gear. This is the bushing. This is the bearing that goes in there. And then here is the armature. The only left is 4 screws in the case. So we're going to try and take this apart. It has 2 glue spots inside. And we're going to try to do it without destroying the case and everything else. But so there's 4 screws we have to take out. Get 1, 2, 3, 4. Remember, this is basically an AC motor with brushes, and because it has brushes, it can be run on DC because it's a brush style motor. And now we have to open it up. So we're going to try to split the case off a little bit here, like that. See that? And get it apart. See, now we got that side off. See, a little bit of glue right there. Another brush here. The other one's shot. And then we try to pull this out of here and get the other side out. There it is. Here we go. There's the other spot of glue. See the glue there? Okay, so you have 2 sides, and then you have the armature, and then you have the what's called the field. This is the field, just like the other one I showed you. Now we're going to try something. Hopefully it'll work. We're going to leave the field out of it and try to run it without the field. They won't run basically without the field, but the brushes have a slot in them. And we're just going to kind of put that together without the field, see what it does. It shouldn't do anything. Okay, there's the motor without the field. This creates a magnetic force around the motor to allow it to work. So we're going to try something here. We have a big magnet here, and we're going to put a magnet on one side of this thing. And then we're going to hook 12 volts to the brushes and see if there's enough magnetic force outside there to make it work. Let's see if it does. No, it's not doing it. Let's see. There. Let's set it on top, like that. I think that'll work. No, it's not working. Maybe there's too much friction there. Let's see, take these out. I got the magnet there. It's a very strong magnet, as you can see. Nope, it didn't work. The magnet has to be closer and maybe more powerful. Anyway, let's try it this way. See if this will do it. There we go. There we go. Got the magnet focused right. There's no field. So let's put the brushes back in. See if it'll, because the brushes put a little friction on it. Let's see if it will work with the brushes in there. So we get the magnet, and it's sitting on top of the magnet instead of it being inside the case. That's a very strong magnet out of a disk drive, an old disk drive. Now let's try this again, see how it works. It's got too much friction. Let's try. Okay, let's try it. Let's try it this way. We'll just do it loose without the friction of the brushes. Just go like so. Get around, yeah. Yes, that works. That's 12 volts. Anyway, that's it for this segment. What we're going to do next is when we run it, we put it together and run it in parallel, which means we're going to run 12 volts through this part here, and then we're going to rewire it so we run 12 volts through the brushes, so it'll be in parallel. And in doing that, I'll just show you what we're going to do here. We're going to take the wire off here and connect it to the wire here so it's in series. So we got to pop this off. Anyway, we got a little finagling around to do, but we're going to make two separate circuits, one for the brushes and one for the field. One for the brushes and one for the field, and that should make it go faster and more powerful. Anyway, thanks for watching. God bless you, and hopefully you'll want to play with one of these things. These are a lot of fun. And this is an AC motor that's also a DC motor. Brush motors are also made to run a DC. So anyway, that's the end of this segment. God bless. Bye-bye.